All right, so in this section, we're going to talk about nullability, which is something that Kotlin supports intrinsically, and it does it rather well, although you have to bear in mind that there are certain issues. Okay, so the idea of Kotlin is that generally null pointer exceptions, or null reference exceptions, to be more precise, are not a good thing. And therefore, when you make a declaration, like for example, when I say var x string equals null, that's not even legal. And the reason it's not legal is because if you use a type just as an ordinary type without any decoration, this automatically assumes that the variable is not nullable. It cannot have the value null, meaning that it always has a string. So if you look up above, you'll see that the main function takes an array of strings. Now it has to be said that this definition, it doesn't just mean array of strings. What it means is a non-nullable array of non-nullable strings. And this is obvious. I mean, if you think about how programs are launched, if you initialize your arguments, then you always have this array. I mean, it could be empty, but it's there. And if it does have any arguments, those arguments cannot be null. It would be ridiculous to have a null argument. So in this regard, Kotlin says that this is a non-nullable array of non-nullable strings. And this is why assignment to a string of a null value by itself will not work. So the question is, well, what if for some perverse reason you do want nulls? How do you do it? Well, one of the possibilities is you make a nullable type. So we say var y, which is a nullable string with a question mark. And here you can assign a null. So here you can say var question mark equals null, and this is okay. So this is a string which can be null or it might not be null. And if something is in fact nullable, then Kotlin provides different ways of accessing it. So let's take a look at an example. So let's suppose I decide to print line the string. Now I can do this because print line is something that's overloaded in Kotlin, and it's actually, very happy to accept an optional string. However, if I try to get the length, and you can see that the length used to be a function, but it's now simply a property. We'll talk about properties later on. Then this becomes completely illegal. Because imagine if the string is actually null. What does it mean to take its length? Well, it's clearly quite meaningless. So Kotlin provides an operator for actually either getting the value if it is there, or returning null if it isn't. So what you can do is you can say something like var length equals y question dot length. Okay, so this question dot is actually called the Elvis operator because this looks like Elvis's hairstyle. So essentially what this gives you is it doesn't give you an int. You might think, hey, I'm going to call this n, and gives you an int. But the question is, well, what about the null case? Is it going to give an int if the string is empty? And the answer is no. By default, it's going to give you a null. So instead of getting an int, you're getting an optional int. And let's actually press Alt Enter and specify the type here. So you're getting a nullable int. You're getting something which is either an int, but it can also be null. And then, of course, what you can do is you can feed it in here. And this is actually okay, because now it's a nullable type. So if it's null, then it's going to print null. And we can actually run this. Let's actually run this with a null to see null printed to the output. So here is null. And of course, if I change it to hello, then we should get a 5 as the output. All right, so hopefully you got the gist of it. So essentially all the variables, unless you put a question mark after them, they are not nullable. You can't assign a null to them, and the assumption is they will never be null. And if you are expecting something which can possibly be null, there are different ways of doing it. So one of the ways is question mark dot and then getting the properties, in which case you'll get a null if y is null. Now let's suppose that you really want a value here. Let's suppose that if the string is in fact null, let's suppose you want a -1. You don't want a null. What do you do in this case? Well, let's get rid of the annotation here. So instead of this, what you can say is, well, if this fails, I want a -1. This is the notation which is kind of like an else. So you imagine you have an if checking for null, and if y is in fact null, then we assign a -1 instead. And now if we infer the type, you'll see that the type is an int. It's no longer a nullable int. It's just an int, because if you do this part, it's going to return you either -1 if it's null, but if it's okay, it's going to return the actual length. So that's fine. That's why in both cases, it's going to give you an int, either -1 or the actual length. So in the case of null, if we run this, we're going to get a -1 because that's now the fallback value. You can see it here. Okay, so final two notes on the whole nullability business. First of all, it would be somewhat crazy if we had to do system calls with lots of null checking. I mean, just imagine something like system.out.println. Now, strictly speaking, any of these could be null. So if we're using system types as opposed to Kotlin, we should have something like this all over the place, basically, but we don't. And the reason why we don't is, once again, thanks to some of Kotlin's magic. Essentially, what Kotlin has done is it's annotated the Java libraries so that in most cases, when it knows that these things cannot possibly be null, it's going to give you the actual type to use without the requirements of these Elvis operators all over the place, because that would be really painful. So there is no problem in doing this. Now, another thing is, what if you are ready for a null reference exception? What if you're okay with it? In this case, what you can do is you can declare things as follows. So let's suppose that I know for a fact that this string is never null. So this string foo, which is declared as nullable, but let's suppose that I know for a fact that I initialized it and I want to get its length, for example. In this case, we use the really ugly and not recommended double exclamation mark operator. So essentially, when I write something like this, it basically tells Kotlin to switch off nullability checking completely. So Kotlin is not going to check whether or not we're actually doing something legal in terms of compilation. So we're talking about compilation, not about the actual execution. So when I write y double exclamation mark, it tells Kotlin that, hey, I know you want to check whether the user is doing something valid here, but please don't. In this particular location, please don't do any nullability checking. And of course, what I can do here is I can get the length, and this is completely valid. It will compile and it will run just fine. Of course, as you can imagine, I'm making the assertion here myself that this is not nullable. Therefore, if I get a null, well, we get a null reference exception or Kotlin null pointer exception, as you can see here. So these are some of the ways in which Kotlin deals with nullability. And certainly, as you use various APIs, as you look at println, for example, you're going to see question marks in certain locations. So if you're printing an int, you're printing an int, but if you're printing something which is nullable, it's going to have a question mark, and that's an indication for you that the API might be, doing something, well, might be expecting a particular nullable or non-nullable type. So it does complicate things a little bit, but it gives you that extra safety in return.